Alright, so today we're going to look at an application of the multivariable chain rule. So let f be a differentiable function of variables x, y, and z. Define new function g using cylindrical coordinates such that g is equal to this. And now let's find the Jacobian. Alright, so starting off, let's write dg r z. And this is just going to equal, so we're treating these as x, y, and z. X, y, and z are actually functions. So within this, g is actually equal to a composition. You know, f composed with g, where this takes r comma theta comma z to r cosine theta, r sine theta, z. Okay, so now that makes things a lot easier. Just apply the chain rule to this. So that's going to be df, dx, df, dy, f, dz. Then we see that g is actually made up of like g1, g2, g3. It's taking r3 to r3. So dg1, dr, g1, d theta, dg1, dz, dg2, dr, g2, d theta, dg2, dz, dg3, dr, dg3, d theta, dg3, dz. Okay, and these derivatives are, well, pretty easy to compute, so let's just do that. Alright, so dg1 dr, that's just derivative of that with respect to r. It's cosine theta. Derivative this with respect to theta, negative r sine theta, and derivative with respect to z is 0. Similarly, looking at this, we see that the derivative with respect to r sine theta, r cosine theta, and then 0. And then finally z, that's easy, 0, 0, 1. All right, so that is the Jacobian in terms of the partial derivatives of f. And let's just also make this a little bit more concrete by taking a derivative at a point. So suppose r theta z, suppose we're trying to find dg of 2 pi over 2, 5. All right. So what is that going to equal? Well, that's just going to equal df, dx, df, dy, dz, and these are all supposed to be evaluated at x, y, z. That's equal to, so we plug these in. So this would be 2 cosine pi over 2, which is 0, 2 sine pi over 2, which is 2, and 5. So these will all be evaluated there. And then you'd multiply it by, well, cosine of pi over 2 is just equal to 1. So that would be equal to, sorry, cosine pi over 2 is 0, so that would be equal to 0. Same with here. This would be equal to 0. This would be equal to sine pi over 2 is 1. So this would be equal to negative 2. That would be equal to 2. Or, sorry, sine of pi over 2 is 1, so that'd be equal to 1. So multiply this out, this, and then we would get df, dy, negative 2, df, dx, and df, dz. And these are all going to be at 0 to 5. And we're done.